Hello, my name is Kevin Kikoza, and today we are going to be diving into the lengthy journey of primate and early hominin evolution. Over the next 10 or so minutes, we'll explore the major fossil discoveries that have shaped our understanding of where we come from, beginning millions of years ago, by tracing the key events and species that have paved the way for modern humans. We'll uncover how our ancestors evolved and adapted to become the species that we are today. To give a brief understanding of how little humans have existed on Earth, take into account that Earth formed approximately 4.5 billion years ago. Its early environment was marked by volcanic activity, a molten surface, and collisions with celestial objects. It took millions of years, but conditions stabilized, enabling the emergence of life. So, here's a detailed timeline of major events in hominin evolution based on the fossils, discoveries, and species that I have found from trusted sources. We start with the Miocene era, which was approximately 23 to 7 million years ago. The first species, the Nyanzapithecus alesi, discovered in Kenya, was an early hominoid believed to be close to the common ancestor of humans, chimpanzees, and gorillas. The next species was the Danuvius guggenmosi, which was discovered in Germany, a species that exhibits both bipedal and suspensory features, suggesting it could be a model for the common ancestor of great apes and humans. That is the end of the Miocene era. We move on to the late Miocene era, which was 7 to 5 million years ago. Starting with the Sahelanthropus chadensis, which was discovered in Chad, is one of the oldest known possible hominin. The fossil shows a blend of ape-like and human-like features, including a chimp-sized brain and a relatively flat human-like face. It suggests bipedalism, marking a significant step towards human evolution. Up next is the Auroran tuginensis, discovered in Kenya, an early hominin fossil that shows both features for both bipedalism from a femur and tree climbing from the arm bones that were discovered. This species was believed to live in a wooded environment. Up next is the Ardipithecus cadaba, discovered in Ethiopia, a key species linking earlier apes and later hominins, showing a combination of primitive features like ape-like dentition and body structure. The final species from this era is the Ardipithecus remidis, Ardi, discovered in Ethiopia, a species that shows a mix of bipedal and tree climbing traits. Ardi's pelvis suggests a transition between arboreal and terrestrial life, and their teeth resemble those of later hominins more than of apes. Ardi's species provides insight into early hominin adaptation to bipedalism. The next era we'll look into is the Pliocene era, which ranges from 5 to 2.5 million years ago, starting with the Australopithecus anamensis, which was discovered in Ethiopia and Kenya. One of the earliest Australopiths showing evidence of both bipedalism and adaptations for tree climbing. This species marks the beginning of the Australopith lineage. Up next is the Australopithecus afarensis, or also known as Lucy, discovered in Ethiopia and Tanzania, a key species in human evolution, which showed clear evidence of bipedalism, though its long arms suggest it could also climb trees. It has a small brain and ape-like features, but provides clear evidence of the transition to human-like locomotion. Up next is the Australopithecus gari, discovered in Ethiopia. This species may be more important in the development of tool use, showing a combination of advanced dentition and body size. It's often considered to be a link between Australopiths and early Homo species. Up next is the Australopithecus africanus, discovered in South Africa, a more derived Australopith with smaller teeth and a more human like face. It may have had a slightly large brain and had some traits that indicate a transition to more human like traits. Finally, is the Australopithecus sediba, discovered in South Africa, a species with a mix of primitive and derived features, including adaptations for bipedalism. Its combination of traits links it to later Homo species. The next era we'll be looking at is the Pleistocene era, which ranges to 2.5 million years ago to 11,700. Starting with the Paranthropus Aethiopicus discovered in Kenya, which was an early robust Australopith showing powerful jaw muscles and teeth adapted for grinding tough vegetation. This species represents a side branch of human evolution. Up next, we have the Paranthropus boisei, discovered in East Africa, the hyper robust form of Australopiths with very large molars and a powerful chewing apparatus. It represents a distinct branch of hominin evolution that eventually went extinct. After that, we have the Paranthropus robustus, discovered in South Africa, another robust Australopith with large teeth and facial features adapted to chewing tough vegetation. After that is the Homo rudolfensis, discovered in East Africa, believed to be one of the earliest species in the genus Homo, showing a larger brain and smaller teeth compared to Australopiths, marking an early stage in the evolution of human lineage. After that, we get to the Homo habilis, discovered in East Africa, one of the first members of the genus Homo, larger brain, smaller teeth, and is also associated with early stone tool use. After that, we have approximately believed to live 1.9 million to 500,000 years ago was the Homo erectus, which was found in Africa, Asia, and Europe, a highly successful species that showed more human-like features, larger brain, smaller teeth, and advanced tools. It's the first hominin known to have expanded beyond Africa. Next is the Middle Pleistocene era, 800,000 to 200,000 years ago. We start with the Homo heidelbergensis, discovered in Africa, Europe, Asia. This species shows a large brain and evidence of more complex tools. Some scientists believe this species is the common ancestor of both Neanderthals and anatomically modern humans. 130,000 to 39,000 years ago, relatively recent, were Neanderthals, discovered in Europe, Middle East, Central Asia, and Siberia. Neanderthals had large brains, stocky build, adapted to cold climates. They used sophisticated tools, cared for the elderly, and buried their dead. They're a close relative of, very, very close relative of modern humans. And then finally, we enter the late Pleistocene Holocene era, which ranges from 300,000 years ago to present time, which is the well-known anatomically modern humans, more commonly known as Homo sapiens, which emerged in Africa and spread worldwide, obviously. Modern humans evolved larger brains and more complex social structures, but over time they developed language, culture, and advanced technologies. Homo sapiens eventually displaced other hominin species, including Neanderthals, and spread across the globe, significantly shaping the planet's environment. So that's the end of the timeline. From the earliest bipedal creatures, like the Sahelanthropus, to the rise of the Homo sapiens, the story of human evolution is a complex and fascinating one. Each fossil discovery gives us a glimpse into the traits and behaviors that have shaped us over millions of years. While many questions remain, these milestones remind us of how far we've come and the ongoing journey of discovery that continues to shape our understanding of who we are and where we came from. Thank you. That is the end.